Throughout the day, we as consumers use different amounts of electricity. For instance, to make coffee in the morning or to watch TV in the evenings. But how does this changing demand affect the dispatch of electricity? And how does it affect the electricity prices throughout the day? Today's objectives are to understand what the electricity demand represents and how it reflects our daily life. In addition, we will explain how this impacts electricity prices, specifically looking at the interplay between demand and supply. So, first, let's look into the so-called daily load profile. The daily load profile presents in a graphical way the total demand for electricity during the day. On the horizontal axis, you see the hours of the day. It starts on the bottom left with the early morning hours and ends at midnight on bottom right. Vertically, you see the load in the system, for instance, the total load in a country. The load is represented in megawatts. The red line represents the load during each hour of the day. You can understand that in the night, when everybody sleeps, there is a low demand for electricity. In the morning, everybody wakes up. Coffee machines are switched on, and it is time to wake up the computers. So, during the course of the day, there is a much higher need for electricity. At night, everybody goes back to sleep again, so electricity demand goes back to a lower level. Please note that it will not go back to zero. There's always a certain demand for electricity, not only for traffic lights and street lights, but also for many industries that run 24 hours a day. In order to meet the demand, generation needs to be available following this demand. Some generators, shown by the blue box in this figure, operate day and night. This is the so-called baseload. For instance, a nuclear power station is a baseload generator because it needs to operate every hour in the day. The time to switch it off or to restart it is just too big. These baseload generators may supply electricity during every hour, but it will not suffice to provide all the electricity during the day. At this time, we need additional generators, which is the so-called middle load. And during the hours with the highest demand, we have the peak load. People return home, turn on the lights, the computers, the televisions. And as a result, we also need to have generators providing electricity during these hours. The issue with electricity is that when there is a certain amount of consumption, the generators need to generate exactly that amount of electricity. There needs to be a balance in the system between production and demand. To meet this balance, electricity is dispatched during every hour. Effectively, this means that we can split the load profile during the day into blocks, where one block represents 1 hour. For each block, the market defines which units are in operation during this hour. For each hour, the market is cleared as determined by the supply and demand curves. The demand is given by the load curve and the price is defined by the market clearing. But how does the market sort this out? In this figure, we have a demand curve represented by the red line. The blue blocks are the supply bits submitted by generators, and on the horizontal axis, there's the capacity, on the vertical axis we have the price. Here there are two things which happen. The first is that in a certain hour, the supply curve and demand curve define which generators supply electricity at the cheapest price. At the same time, for each hour, the supply and demand curve dictate the market clearing price. This price applies for that hour for all electricity sales. The market clearing happens for every hour in the day. Here we have two moments as an example. During the night hours, in the left diagram, demand is low. When demand is low, of course, you don't need much generation. And the cheapest generators, in this case the base load generators, will set a price. So during the night, the electricity price is typically low. During the peak hours, we have a much higher demand represented by the right diagram. And because the demand is higher, we need the more generators that run at a higher cost. Since the price is set by the marginal generator, the resulting electricity price for this hour is also much higher. These points become clear when you place the demand and supply curves beside the load profile. We have the load profile runs throughout the day. During the night hours we have lower demand, during daily peak hours we have higher demand. As a result, the price during the night hours is different from the price during the peak hours. During the day, market prices change according to the changing demand. But they also depend on the available generation in each hour. For instance, solar power will be available only during the day hours, but not during the night hours. What effect do you think does this have on market prices and electricity dispatch? What do you think would happen if we introduced a large proportion of solar power into the energy mix?